Hi everyone, in case you forgot my name, it's Ravi and I'm your instructor for Math 6. In this section we're going to be talking about functions today. So we've already dealt with functions, we just haven't formally talked about them. So, well, what is a function, right? So a simple definition of function is nothing but a relationship, right? So I could say a function is a relationship between two sets, right? But not just any relationship, it has its own restriction, and we'll see what that is. But this is sort of a very layman's definition of what a function is, okay? More specifically, so here's an example of a function, right? The distance you travel is a function of time, right? The more time you spend, the more distance you travel. So that's a function. Another example of a function could be up to a certain age, right? Your height is a function of your age. So the older you grow, the taller you become. Obviously that ceases after a while, but until that age, you can say that height is also a function of your age. So what does a function exactly do? So let's look at a couple, before we define what a function really is. Okay. So before we define what a function really is, let's go ahead and look at what is this function doing, right? So let's say I have, for example, so I think of a function as, so think about your soda can, the machine that dispenses soda cans, right? What happens? You put in an input, that is, you put in your dollar or your quarter or whatever that is, you press a button and out pops a soda can, right? So that is a function, right? So you're putting in an input, something happens in there, right? And then you get an output, and that is exactly what functions do. So what a function does is, let's say I have two sets, right? Let's say I have a set x and a set y, right? And I'm just going to go ahead and draw these sets over here. This set has some elements. Let's call this A, B, C, D, and E. Okay, what my function does is, and then let's say first of all y has some elements, say 1, 2, 3, and 4. Now what my function does is it takes every element of x and it assigns it a unique element in y. So for example, it'll take, let's say this is my input, so it's going to take A and it's going to say I'm going to take A to 3. So I'm going to assign A to a element 3, which is in y. Okay, it's going to take C and say it assigns it to 1. Okay, now it can only assign it to one element. So I cannot say that, oh, C goes to 1, but C also is assigned 4. So if I did this, if I assign C to 4, then it's no longer a function. This cannot happen. C has to be assigned only one element. Okay, so okay, so C has to be assigned only one element. Well, now you say maybe, well, B doesn't need to be assigned anything. Well, that cannot happen either. B has to be assigned something. Now B can be assigned a completely different element, so I can have B assigned to 4, or B can be assigned to one of them that is already chosen. That is okay, because look, A and B are assigned exactly one value. It so happens that that value they're assigned to is the same, but they individually are assigned only one value, so that is fine. And then let's say D is assigned to 2, and then let's say E is assigned to 4. So this is what your function is doing, is it's picking these values from x and is assigning it to values in y. All your values in x have to be picked up and have to be assigned to y. I might have certain values in y which might not be, so nothing is assigned to 5, for example. That's okay. But everything in x has to be assigned to something. Okay, that is exactly what a function does. So let's look at a definition, a more formal definition of a function. So a function from a set x to a set y is a rule that assigns each element in x a unique element in Y. Okay, so and when I say unique, it means exactly one. All right, and we say that the set X is the domain of the function, and the set of assigned values in Y is called the range of the function. Okay. So now that we have defined the function, how do we write it down? So we always don't want to write a big long text, so we want to write it down in terms of symbols. So what we say is, if we say that f, so suppose f is a function from x to y. So we write that as f colon capital X to y, right? So that is, f takes elements from x and assigns it a unique element in y. So let x be an element in capital X and y be an element in capital Y. So then we say that y equals fx. Okay, so we say y, we can read this as y equals, we read this as y equals f of x. Remember now, this is not f times x, and f without the argument x doesn't really make sense, right? So you have to write f and x together, and this is not a multiplication, it is f of x. It's a function of x. So x is what we call an argument for, sorry, x is what we call an argument for f. Okay. So now we can represent functions in 3 different ways. I'm just going to list them out here, and we're going to look at them more in detail in the next video. But how do we represent functions? So the 3 ways we represent functions, one is using algebra, right, or precisely y equals fx. Okay. Second, we can represent them using graphs. All right. And third, we can use them with set notation, right, or ordered pairs. Right? And like I said, we're going to take a look at them more in detail in the next video in an example.